Introduction. We choose this topic because this method shows how to sketch the graph. There's the two types of function, which is polynomial function and rational function. There are 6 ways to determine the graph. Firstly, find the y-intercept and x-intercept, and then find the critical point of the function. After that, find the interval decreasing and increasing and their relative extremum. A little bit different with the rational function, where we have to find vertical and horizontal asymptote. With all the information, we can decide the shape of graph with the concave up or concave down and find the inflection point. Finally, we can sketch the graph. So right now we have the problem statement of polynomial function, where function is equal to 1 over 3x cubed minus 2x squared plus 3x plus 1.
First, we have to find y-intercept. So, how to find y-intercept? What we can do is, we need to do x equals 0. Then, we will get the answer, which is 1. And the point is 0, 1. Second, we need to find the interval increasing and decreasing. So, how to find it? The first step, we have to find critical point by differentiate the fx function, and after that we need to equal it by 0. And we will get the critical value, which is 3 and 1. Next, we can find the critical point by substitute the critical value to the original function. And we will get the answer of critical point, which is 1, 7 over 3 and 3, 1. The last step to get the interval increasing and decreasing is, we need to construct test table which include 3 and 1 as interval. As shown in the slide, we have to choose any number between these 3 intervals and we substitute it to f prime x function, and we will get the interval increasing and decreasing as shown in the slide.
So we find the interval increasing and decreasing, we have to determine the relative extremum. So in order to find the relative extremum, which is maximum point and minimum point, we have to find the second derivative, which is in here. We got the 2x minus 4. So after that we have to substitute the critical value, which is x equals 1 and x equals 3. So after we got the answer, is maximum point is 1, 7 over 3 and minimum point is 3, 1.
To find the concavity, we will need to use the second derivative. Then set f double prime x equals to 0 to find x, which is the inflection value. The inflection value is equals to 2. Then use the test table to find the concavity. Pick number between the interval for the test value. 2 to infinity is the interval concave up, and negative infinity to 2 is interval concave down. Next, you need to find the inflection point. We need to substitute the inflection value to the original equation to find y. 5 over 3 is the inflection point. Then we need to collect information before do the sketch.
So right now we move to the second function, which is rational function. So fx is equals to 4x squared minus 36 over x squared minus 2x minus a.
So, y-intercept and x-intercept. In order to find the y-intercept, we have to change the x in the function to 0. Therefore, we will get the f in the function of 0. After we done that, we will find that our function to 0 is 9 over 2. Therefore, our y-intercept coordinate will be 0, 9 over 2. How about x-intercept? For x-intercept, we have to change the function the fx equals to 0. So the whole equation here will be 0. So after we do a bit of counting, we will get that x equals to plus minus 3. Therefore, our x-intercept has two coordinates, which is 1 is 3, 0 and 2 is negative 3, 0. How about vertical and horizontal asymptote? So for vertical asymptote, what you have to do is we have to get the denominator equals to 0 because we want to find the rational function, right? Therefore, when we equal the denominator to 0, we will get that our first x will be 4 and our second x will be negative 2. Therefore, our vertical asymptote has two places, which is x equals to 4 and x equal to negative 2. For horizontal asymptote, what we have to do is a bit complicated, but it's actually a bit easy if you practice more. What you only have to do is that you have to make sure that you put limit x into heading to infinity, and for this part you have to search the highest power of the denominator. In this case, the equation right here, right, you can see the highest power is x squared. Therefore, we have to divide all of the numbers in the equation to x squared, as stated on this picture. Therefore, after a bit of counting, we will get that our horizontal asymptote is y equal to 4. For interval, there's a two-part that we have to do, which is first one is to find the differentiation of the function that we have, which is fx equal to 4x squared minus 36 over x squared minus 2x minus 8. So we need to differentiate it to become f prime x. In order for us to do that, we need to use the quotient rule because our equation is rational function. Our function is rational function. So we use our quotient rule, which is basically vu prime minus uv prime over v squared. So as you see right here, u equals to 4x squared minus 36, v is x squared minus 2x minus 8, and u prime is 8x, while v prime is 2x minus 2. Therefore, we will get that f prime x is stated as the picture. Now, after we find the f prime x, what we need to do is we have to use a table for testing. So we have to make an interval using the vertical asymptote that we have earlier, which is x equals to 4 and x equal to negative 2. So we have in this case three intervals, which is the first interval is negative infinity to negative 2, second interval is negative 2 to 4, and third interval is 4 to infinity. And then each interval we need to use the test value which in the range of the interval. Like for in this case negative infinity to negative 2, we use the test value of negative 3, and henceforth. After we decide all the test value, right, what we have to do is we have to use the equation of the f prime x that we got. We have to use the f prime x that we got. We will get our result that every answer to that f prime x will be all in negative form. Therefore, if f prime x we got all negative, it will be interval decreasing, while f prime x is positive, it will be interval increasing. But in this situation, we don't see any positive whatsoever. So therefore, all of this interval is interval decreasing. For concave, we just need to do the same as the third step earlier, which is how to find the interval decreasing or increasing. But for the context of concavity, we have to change our f prime x to f double prime x. So we need to do a double differentiation on that. So take your f prime x earlier and you differentiate it again. Again, we're using quotient rule because these are rational function. So after we do a bit of counting, we will get our f double prime x is this, stated in the picture. So after we find the f prime x, we need to make a table again and do the same thing all over again like we do on the interval. Just to find the test value, look at the f double prime x, answer and all that. So as you see right here, that our interval of negative infinity to negative 2 is negative, our second interval negative 2 to 4 is positive, and 4 to infinity is positive. So for positive f double prime x, we use we make it concave up, while f double prime x of negative, we use it concave down.
The conclusion that we find is, by examining the second derivative of function, we can draw the conclusion that the concavity of function can be found. Additionally, we notice that a function has the ability to switch concavity.